The next topic I want to talk to you about is a little bit outside of schema design, and it's a topic of how do you store large files within MongoDB. These are files that are larger than 16 megabytes. So there's a 16 megabyte document limit within MongoDB, and if you want to store something larger than 16 megabytes, you need a way to do it. And GridFS is the way you store these large objects within MongoDB. And these objects are sometimes also called blobs. Now, MongoDB has a facility called GridFS, and GridFS will break a large blob into pieces for you and store it into some collections. So, how does it work? Well, let's say you had a large file, and you want to put that file into MongoDB. MongoDB will break it up into two different collections. One is a chunks collection, and in the chunks collection, it will put one document for every 16 megabytes of data that exists within the document. So it'll break it up into 16 megabyte chunks and put it into the database in the collection. And then there's a files collection, and it'll put a single document in a small document that will describe the documents that it put into the chunks collection. Now the _ID that is used in this files collection will be put into this chunks collection. For each of the chunks, they'll each have a file ID that corresponds to the _ID for the meta document in the files collection. Now let's look at an example. I've got a video file in this directory, video.mp4. If we look at this file, we can see that it's about 95 megabytes. And we can open it up, and you can see it's a video that can be played. And what we're going to do is we're going to write a program that's going to put it into MongoDB and then take it right out of MongoDB. It's actually going to put it into this video copy file. It'll copy it into a file called video copy, which will be here when we're done. Right now it's not here. So let's look at the IDE and go through the code. I've written a GridFS test. You can see I've created a new Mongo client, and then I just get my database, which is called course. And now I'm going to create a Java file input stream called input stream. And then I'm going to create a new GridFS object. And this doesn't really create the GridFS system, it just gives you an object that lets you manipulate it. And then in this case, I have to associate it with the DB, and I also have to give it a name, which is called videos. And now, as we go down, we're going to open up this video file, video.mp4, and there's some exception logic to make sure that the file can be found. And then we're going to create a new handle for a new GridFS object. And we're going to do this using this create file method right here. Video is a GridFS input file, and videos is a GridFS object. So we're taking that GridFS object that we created up here, and we're going to call create file on it, and we're going to give it the input stream to this file on disk, this video.mp4 file. And then just because we want the name to persist inside MongoDB, we're going to tell it that it's called video.mp4, because otherwise MongoDB would have no idea what file was originally associated with this input stream. Now GridFS has a facility to let you put other metadata inside the object as well, so we're going to do that. What I've done is I've created a new basic DB object, and I'm going to have a description, which is Jennifer singing. And then I created an array list here of tags. I'm adding some tags to it, singing and opera. And I'm going to append that to the metadata as well. And then I'm going to set the metadata on my video object. This is the GridFS input file object. And then I'm going to save it, and that's going to save it to the collection. And after that, just for grins, I'm going to print out the object ID that was assigned to the document in the files collection. Then I just say that I saved it, and now I'm going to read it back out. So how do I read it back out? Well, I create a new type of object called a GridFS DB file. You'll notice this is actually a different type of object than I used to input them. So it was a GridFS input file when I wanted to put something into MongoDB, but it is a GridFS DB file when I take something out of MongoDB. And I'm going to do a find one, and I'm going to find the file name video.mp4. And I'm able to do that because I actually stuck that information into it over here when I associated this file name with this GridFS object. Now after I do my find one, I'm just going to open up an output stream with a name called video copy.mp4, and then I'm going to tell GridFS to write it out to the output stream onto disk. And that's the whole program. So let's run that and see what happens. You can see that it ran. It has an object ID starting on 513, saves it back out. Let's look in the directory, see what we find. So now we see there's a video copy, And if we open video copy.mp4, I'll have to bring this over to show you, but there it is. It's the same video as before, so it seems to be intact. Now let's look at what happened within MongoDB. So we were in the course database, so use course, and we're going to show collections. And now we see there are two new collections in here, chunks and files. Let's look at the files collection, db.videos.files. There's actually one object inside there. It's the metadata describing this video file. You can see that the video.mp4 file name has persisted because I associated it with the gridfs object. There's an upload time, and the metadata that I put in is right here. So the description, Jennifer singing, and the two tags are sitting here in the metadata collection. And I could query on this files collection using that metadata if I wanted to find this object again, versus using the file name, which is what I used. Now, there's the object ID 513. So let's look at this other collection, which is the chunks collection. Let's see what we see there. And we're going to see a whole bunch of stuff. All right, I'm going to print it out again, but this time I'm going to suppress printing out the actual data field to make it a little bit easier to read. And I'm going to print it out pretty. And you can see that I've got 19 chunks for this object. I'm not sure if they start with 0 or not. Let's see if they start with 0. Like all good things in computer science, they start with 0. So yes, so there are exactly 20 chunks. And I've suppressed the data field, so it looks like these are small documents, but they're actually probably pretty close to 16 megabytes. And you can see that the file ID here is actually the object ID from the files collection. And that's how they associate the different chunks with the original files collection. Now, I just want to point out that there's nothing special about that file name field in the files collection. And if I run the program again, I will have two chunks with that file name. So let me just show you how that would work. So I'm going to run it again, and now I'm going to go back to my terminal, and then you can see now I have two documents, both with the same file name. So it's up to you to keep those file names unique if that's the way you want to search on these gridfs objects in the future. But of course they have different object IDs, and it's these object IDs that actually tie together the metadata with the chunks themselves. All right, let's do a quiz. Which of the following statements are true about gridfs? gridfs stores large blobs in a single collection by breaking up the file into multiple pieces. Each gridfs document is given a unique file name. gridfs stores large blobs in two collections, one for metadata and one for the blob chunks. And gridfs compresses your file on disk. All right, so which one of these is true? And I know that one of them I didn't actually give you the answer to, so you'll have to guess on that one, but so just do your best.